Woongsong is a research scientist of the BC Ministry of FLNRORD. He is from South Korea, acquired a Bachelor of Science and a Master of Science in Forestry at Seoul National University. He finished his PhD in forestry at the University of Montana, USA, with a concentration in silviculture. After working as a postdoctorate researcher for several institutions in the USA and Canada, Woongsong joined the BC FLNRORD last year, focusing on research of fertilization and forest nutrition. Woongsong, up to you now.
Yeah, can you hear? Thank you. Screen. Can you see? I only have one screen, so let me know if there's a technical issue.
That's a good screen there if you want to put it into presentation mode. Yeah, perfect.
Okay. Good afternoon. My name is Jang. You can say anything, Jang, Yang, Woongsong, because even my kid cannot pronounce my name correctly, so it's okay. Nice to meet you. I'm happy to present my research about the fertilization in British Columbia. I just start to work in the BC ministry last year, and then I start this work within very special time. So I have limited to meet new people, but through this good opportunity, I am very happy to meet you guys, even remotely located from BC. So one thing I was very excited about this position was basically fertilization was very rare and unique and intensive practice in silviculture. So like other country or region like South Korea or Montana, nobody think about the fertilization on forest. So when I heard about this position and I was excited, actually I become very special and unique when take this job. So BC actually do fertilization a lot for me. And then two major programs was involved this fertilization in BC, the Forest for Tomorrow and Forest Carbon Initiative. So those two programs has slightly different goals. For Forest for Tomorrow, they aim to maintain sustainably supply timber in the future, and FCI want to increase carbon sequestration by fertilization. So fertilization is quite attractive because we can increase the timber volume or carbon without sacrifice of the temporal loss of the tree volume. So many of other countries, I think, have interest in the fertilization nowadays because of the carbon emission, carbon sequestration issues. But the problem is fertilization response of a tree is impacted by many other factors. So definitely fertilization blend rate can determine the magnitude of the fertilization response. And each species has different trait like shade tolerance or some specific nutrient requirement. So each species should respond differently to the fertilization, and stand condition also affect to the fertilization, and a lot of other biotic and abiotic environmental factors also determine the fertilization response. So because of the fertilization is quite expensive management practice, so the understanding of the fertilization response is very important for the cost-effective management. This day, I want to present the research what I have been done past 3 or 4 years in BC. Thankfully, and then fortunately, I have had a good opportunity to involve interior coastal fertilization project. So for the interior forest, I have been involved to improve the fertilization official government support growth and yield model interior BC. So this it is not the growth and yield model per se, but it is the standard level of interpolation yield, interpolated yield table generated by TAS. TAS is another tree-level growth and yield model. So TAS is kind of the computing heavy require the computing power require computing powers and then complicated to use. So the government developed the TIPSI for the user's convenience. So basically, TIPSI also have fertilization module. So TIPSI, the screenshot, I'm not sure you guys, I'm not sure you guys can see my arrow, but these are the screenshot of TIPSI and fertilization mode, TIPSI and TAS. And TIPSI has its own fertilization module, and the users can customize fertilization response, or they can use the default value of the ministry set. So this table is a screenshot of for the lodgepole pine fertilization response set by ministry standard. This table was so the TIPSI using this table and then interpolate the predict the fertilization response through the interpolation of site index, given site index and age. But the problem is, this is I generate this contour map of how the emulating how the TIPSI interpolate this table. And as you can see, this is a very steep transition regarding the fertilization gain, but there's no kind of evidence, the scientific base how this happened. So what I did is I collect all the EP data across the PC and then analyze using statistics. Then I developed equations, fertilization equations. As you can see this. So we, using this equation, the users can estimate the fertilization response by fertilization blend, and then by time, years after fertilization, and stand density and stand ages. So we are hoping that this equation is replaced, the TIPS is the interpolation module, so that users can more flexibly estimate the fertilization response. And we trying to do some validation work, this one. So I asked the many folks in Alberta and Idaho, so we got some independent data, and then we validated. So we found that our equation is slightly better than the interpolation of the TIPS table, but the number of the data is not big enough, so we cannot publish it yet. But I want to use this opportunity. I want to thank to Dr. Jim Stewart to provide valuable data for the validation. And one more thing I want to introduce to you about interior fertilization research was you guys know that, people know that the foliar nutrient analysis provide a very accurate and relevant information about for diagnosis of the nutrient status of the trees. So people can interpret the status of the nutrient, and then they can, it is very useful to prescribe the fertilization. But the problem is, even there are many resources and tables, but it is oftentimes the interpretation of the fertilization lab result of the foliar analysis is not straightforward. So for example, like sulfur, the actual amount of the nutrient, the sulfur in the foliage is less relevant to diagnosis the nutrient status than comparing to other nutrients like nitrogen and sulfur ratio, those kind of stuff. So many practitioners have confused and then have no idea how can interpret their numbers. So I found that about 20 years ago, actually, the scientists in BC and Pacific Forest Center, they developed an app, but later the researchers retired, the web was lost, and then I revived this app application and rewrite and update using R Shiny, so that everyone can use for free. And then now this app is hosted in our government website, and people can use it. So let's move to the coastal region. For now, I am focusing on the Western hemlock fertilization response for now, because Western hemlock is one of the most common species in coastal region, and one say that it is about 85% of chance if you pick one single the forest inventory, then you can find at least one Western hemlock. And according to the vegetation inventory database, I calculate the pure hemlock stand area, and then it shows that almost 0.7 million hectare was pure. That means the hemlock breeding stand. And the problem is that this hemlock fertilization response is had too high variations. It is so that in the tipsy the fertilization module, the default value of the fertilization response is set to 0. So in the manual and the help file, they recommend to create their own custom response model to predict the fertilization response and after growth. So the Western hemlock fertilization research data is quite rare, and so we use the stand management cooperative, which the BC Ministry is a member of the co-op, and then we I got the data from them and then analyze the fertilization response. As you can see, there some installation has a negative response, some has positive. So these are clearly showing that it has high variation. For fertilization response. But one promising news about the fertilization response of hemlock is in BC, particularly for the Vancouver Island. There are several the Western hemlock fertilization trials, but those trials showing very positive and outstanding fertilization response to hemlock. So one of the representative trial is the SHERP, the Solar Cedar Hemlock Integrated Research Program. It has been established from in 1980s to 1990s. And this SHERP site showing the clear fertilization response regardless of the site. As you can see, some site even showing 10 times of the high growth compared to the control. So this implies we have to take into account more factors, as well as we have to zoom in to the data. So I did analysis on the tree level. So what I found comparing these two data sets from the very fine level analysis is mortality is not affected by fertilization in Canada. But from the USA data, the mortality is affected by fertilization. Actually, fertilization increased the tree mortality, and this fertilization effect is interact with stand density. So the higher stand density increase mortality. That makes sense. But interesting thing is, if you fertilize, then the effect of the density on mortality will be decreased. So fertilization decrease actually tree mortality.
1 sec.
And also I compared to the growth response of fertilization of hemlock, and fertilization clearly increased the height and volume growth for both countries. But it is interact with other factor the individual factor BALR. BALR is relative basal area of larger trees in the given plot. So you can think it is just a rank of the tree in a plot. So for example, BALR is 0, then is the biggest tree. BALR is 1, is the smallest tree. So the smallest tree grows less. Yeah, it does not. It doesn't surprise. But if you fertilize, then the smaller tree can grow better in Canada. But in United States data, smaller tree, if you fertilize, then it grows less. So the major difference between two, there are many different factors can be involved, but one, we have this result implying that we have to think about take into account those the stem development stage, because the Canadian data is all Canadian data was fertilized at plantation, but the United States data, the fertilization is fertilized near the stem exclusion stages, so that the competition was very high. So we are now start to new experimental design, so that we want to measure the fertilization response from the tree level. So we implemented individual tree level experimental design, collaborating with SMC. So each tree, as you can see, this grid become a plot, and each tree become one plot, and then grouped, and then randomly apply the different kind of fertilization. So we currently last year we established 3 sites in the Vancouver Island. We will add more and more if we get funded. So one thing I want to introduce from the SHARP result was SHARP showing very outstanding growth response of hemlock, but very well-grown hemlock showing higher the sinuosity problem. So as this figure showing very squeezable speed wobble of the hemlock trees. So this year we'll take some foliar nutrient analysis about this speed wobble tree, so that the speed wobble tree has some nutrient issue. And I'm also have interest in the fertilization response to the wood quality or forest health issue. For example, when I analyzed the interior dollar spur and spruce and raspberry pine, then there are many trees were attacked by red squirrel or western gold rust, mountain pine beetle, and the white pine weevil. Those can be or may not related with the fertilization. We didn't do any the statistical analysis yet, but I want to figure out any relationship between fertilization and damage. The fertilization also have different result in terms of the ingrowth, small trees. This is a result from the SHARP. As you can see the fertilization and the planted species make quite different species composition of ingrowth. So this one, I didn't deeply look into those difference of this result yet, but hopefully I will dig into what's going on, and then I wish saying some interesting story about the ingrowth. So for now, I just introduce my personal research interest and then the past research. But there are many other enthusiastic scientists and silviculturists in BC. So they are already involved somewhat fertilization research so that they can answer about many different topics like timber, wildlife, water, the carbon. So I hope I will do collaborate as many as possible, and then want to involve and contribute to improve our understanding of fertilization impact on BC forestry and Canada. Thank you for listening my presentation, and then do you have any question?
We do have time if it's a short question. So I'll give it just a few seconds here to see if something pops up, and if not, we'll move on to our next speaker. All right, thanks a lot, Woongsong. I think if people have fertilizer questions and growth response and that kind of stuff, they'll get a hold of you. Thanks you for your time. Thanks for participating in this presentation.